All right, welcome to Meaning of Logarithms, right? So starting off, rewrite each equation in exponential form, right? So you remember the from the lessons, log base 6 is going to be exponential base just as well. So that's going to turn into an exponential base of 6 to the second power equals 36. And that's your exponential form. So log to exponential, right? That's how it's going to work. So number 2, this is going to be log base is 289. So it's going to be exponential base 289. That means it's going to be a big number. And then the equal part becomes your exponent, 1/2. And then your argument for the log becomes your equal in the exponential, right? And you can double check that, right? You can type on your calculator 289 to the 1/2 power, and that's going to equal 17, right? Or 1/2 power, you may know that as a square root. So the square root of 289, you can check by yourself, but that's going to be 17. Okay, number 3, same scenario, right? So log base 14, so that means exponential base 14 to the negative 2 power. That's going to make 1 over 196. Okay, number 4, that's going to turn into exponential form of 3 to the 4th power equals 81. Right. Okay, and you can check on the calculator, and that would be true. Actually, you can even check it now. 3 to the 4th power is 3 times 3 times 3 times 3. And we know each 3 is 9. So 9 times another 9, and that does make 81. Okay, so checks out. Okay, second part, rewrite each equation in logarithmic form. Okay, and this is just going exactly the opposite. So if we have a exponential base 64, then we're going to end up with a logarithmic base 64, right? And then the 8 becomes the argument part, and the exponent, just like how we had before, becomes goes on the other side of the equal, is what the log is equal to. Okay, so keep going on this. Oops, let me get rid of this first. All right, so this is going to be log base 12, because this is exponential base 12. Log base 12 to the or of 144 is going to equal 2. Okay, this one right here, it's going to be, since it's exponential base 9, then we will have log base 9. And the base 9 for log is a little teeny tiny subscript. All right, so log base 9 of 1 over 81 is going to equal, and then the exponent is negative 2. This one right here, this is an exponential base 1/12. So we're going to write it as a log base 1/12 of 1 over 144. Okay, and that's going to equal, that's going to equal to the power of 2. Right, or it's going to equal 2, no power. Okay, 9, 10, 11, 12, 13, 14, same kind of scenario. Rewrite each equation into exponential form. So if we rewrite this, this is going to become u to the v power equals 15 over 16. And the direction doesn't say anything about solving, so we're just going to leave it like that. Okay, this one's going to turn into v, because that's the log base. So v to the 4th power, that's going to equal u. Okay, number 11, we have the base log base 7/4, so that turns into exponential base 7/4 to the y power. Now you can write like that, but if you get confused, definitely put a parentheses, because that means that 7/4, the whole thing, the whole quantity, is to the y power, and that's going to equal x. Okay, this is going to equal, or turn into, log base 2, so that means we're going to get an exponential base 2 to the power of u, and that's going to equal v. Okay, this one, number 13, log base u, so we're going to have exponential base u to the negative 16th power, and that's going to equal v. Okay, number 14, we have a log base y, so we're going to have exponential base y to the negative 8th power. That's going to equal x. All right, so that's the next part. Okay, 15, 16, and I presume all the way to 20, 15 through 20. Oops, sorry. No extra scribbling. Okay, so 15 is rewrite each equation into logarithmic form. So again, same scenario, just which is more generic generic characters, right? So if this is a exponential base u, then we're going to be writing this in logarithmic form as log base u. And then this is to the, or of the argument v, and that's going to equal negative 14. Okay, same thing with this one. Okay, so exponential base 8, that means that we will end up with log base 8, and of a, and that's going to equal our power, which is b, which is no longer an exponent, no longer a power. Okay, 17, same instructions, so that's going to turn into log base 1/5. So very teeny tiny 1/5. I know 1/5 is already teeny tiny, but that's even a smaller number. And then this is going to be to the y, or of y, and it's going to be equal to x. Okay, this one, we have log base 6, because this is exponential base 6. So log base 6 of x, and that's going to equal y. And you don't have to put parentheses, but you could. I mean, it doesn't hurt to put parentheses. Here, I'll put it as a dotted or invisible parentheses. Right? So it kind of depends. For me, it just depends on how it all looks together. If it looks a little cluttery or a little sloppy, then I'll put parentheses. But like number 18, you didn't need to put parentheses because it looks nice and clean. Okay, so 19, we have exponential base 9, so we will have log base 9 of x, and that's going to equal y. And then again, what I said about the parentheses. Okay, so this is going to transform into logarithmic base b of 123, and that's going to equal a. Okay, that was fun. I actually enjoy doing that. Okay, the rest of these, we're going to go ahead and evaluate these expressions, right? So for example, right, we want to know, what is this log base 4 of 64 equal to? What is that equal to, right? You can put an X, or you can put a little blank, or you can put a little box. Actually, let's put a little empty box, right? So what is that? What is that equal to, right? So in order to get that, you have to kind of rewrite this. So I'm going to rewrite it down here. A little different from what I've been doing, but I'm going to rewrite it as exponential base 4 of the equal part, which is now going to be the exponent, and that's going to equal 64. Right? So I need to figure out 4 to the what power equals 64. And that whatever the what power is, that's going to be my answer to the logarithmic expression. So 4, so let's think about this. So 4 Actually, let's put it in different color. Right? So 4 times 4 is 16. 16 times 4, so I don't know what that is, but 16 times 4, that's 24. 4, 5, 6, so that's 64. So it is just 3 of these. So my correct answer would be if that was a 3. If there were 3 of these, then that means that right there should be a 3. So log base 4 of 64, the answer is 3, right? And all we did was utilize the exponential equation down below right there to figure out that it was 3. Okay, so we're going to do the same thing. So again, I don't know what the answer is, but I'm going to go ahead and figure it out. Right, so that's the answer. But I'm going to go ahead and transform this into an exponential equation. So this will be 6 to the power of something. That's going to equal 216. So if you want, you can take your calculator, but I'm going to, since I don't have a calculator or I didn't open one up for me, I'm going to go ahead and try to figure this out by hand. So 6 times 6, okay, and that's definitely not 216, but that's 36. But I want to see what happens with one more. So I'm going to times it by 6 again. And I don't know what that is. So I'm going to go ahead and go 36 times 6, which makes 36. And 6 times 3 is 18. And then add 3 more, 19, 20, 21. So that makes, hey, and it works out. So my answer is 3 of these. Okay, so I will need a 3 right there, which means that log base 6 of 216 is going to be equal to 3. Okay, if you need more time to think about it, just pause the video anytime you want. Okay, again. So let's just go ahead and just kind of jump to it, right? So what is this log base 4 of 16? What is that equation equal to? Well, that's just 4 to the something equals 16, all right? And we know that 4 times 4, or 2 of them, 4 squares equals 16. So then we know that our answer is going to be 2, right? So see if that makes sense. If not, okay. But I'll kind of go like this for a little bit and see if it catches on. That way we don't have to spend so much time drawing arrows and invisible boxes, right? So this next one, this is going to be exponential base 3 of something, and that's going to equal 1 over 243. Okay. Now, just thinking to myself, if I go 3 times 3, that makes 9. That's not 243, or even 1 over 243. And if I go times 3 times another 3, that's another 9. And 4 of those actually just make 81. So I'm not even quite there yet. Right? So I may have to multiply by another 3. And I don't know what that is, so I can go ahead and try. Okay, so if I multiply by another 3, I'm going to put a 3 here. Right? So I got 3. 3 times 8 is 24. And look at here, I got what I'm looking for. So it's going to end up being 5 threes. Okay. But the problem is, if I just put a 3, if I just end up putting a 5 here, I will actually get 243. Okay. I won't get 1 over 243. Okay. So think about what needs to happen, because I need to have a fraction where I need that 243 to go to the bottom of my fraction. So if you've got it, okay, it's going to end up being -5. Because the negative forces the 3 base to go to the bottom of the fraction. So log base 3 of 1 over 243, the correct answer is going to be just -5 is my correct answer. Okay. So in a second, you hear the bell because I'm doing this during 7th period. Just excuse the interruption. Okay. So working on this one, we get 5 to the what power equals 125. Okay. So you might notice that it's 5 times 5 times 5, right? Or if you think about it, 5 times 5 is 25. 25 times 5 is 125. So the answer is going to be equal to 3. Okay, because 3 of those makes 125. All right. Next one, we got 2 to what power equals 4? Oh, there's the bell. And you know that 2 squared is equal to 4. So we know that our answer is going to be log base 2 of 4 is going to be equal to 2. That's the correct answer. Okay. This one's a little tricky. The next one, 27. Okay. 343 to what power would equal 7?
Good afternoon, students, and happy Friday. Everyone have a safe travels to Pismo. Enjoy the weekend.
Oh, I
For
did not know
today's
that.
after-school treat are Planters Trail Mix, string cheese, apple slices, grapes, Chobani yogurt, celery sticks, chili lime carrots, and milk. Weight room is canceled for today. Glass Painting Club, 7:03. In the library, we have gaming, chess, Lego, and virtual reality club. Remember, there is no late buses on Fridays. Once again, everybody have a wonderful, restful weekend.
All right. So 300, 343 to what power is equal to 7? Right. So that's a little tough. Right. Let's think about this. Right. So find out what number. So it looks like it's gonna be it's something that multiplies by itself to make 343. Okay. And if you go through some of the numbers, okay, if you want to try it for yourself, or you should be trying it for yourself, pause the video. But it comes out to be 7 times 7 times 7. Right. So in order for this to work, right, this is going to be, so basically what times what times what makes 343? Well, that's 7 3 times. So in order for this to work, it's going to have to be 1/3. Okay. And if you try on the calculator, okay, 343 to the third power, which is equivalent to a cubic root of a cubic root of 343, meaning what times what times what? 3 times makes 7, and that's what it is. Okay, so your answer is going to be 1/3. Okay, so log base 343 to the of 7 is equal to 1/3. That was a little tricky. Okay, especially because the base is big and you kind of have to work backwards. All right, next one we got 16. Oops, excuse me. Next one we got 2 to the power of what is going to equal 16, right? So we know that 2 times 2 is 4, times 2 is 8, times 2 is 8 times 2 is 16. So we know that there's going to be 4 of those. So our answer is 4. Right. Okay. Number 29, we got 4 to the power of what would equal 64. And you're going to have to look at your multiple versions of 4. So go ahead and work that out. If you don't know yet, pause the video if you need to. But that's going to be 4 times 4, which is 16, right, times 4. And I don't know what that is, but if I do the multiplication, 6 times 4 is 24. 24. 4 times 1 is 4, plus 2 is 6. So it's 3 times, right? So we know that this is 4 to the third power would be 64. So therefore, our answer is going to be log base 64 of 4 is equal to 3. All right. And the last one for that chunk, we have 6 to the what power is equal to 1 over 216. Right? Again, it's going to be the same scenario as I believe number 24. If you look at number 24, because it shows up as a fraction, and you know I'm pretty good with my times table, and I know that there's going to be a version of 6 times 6 times 6, you know, however many times it's going to make 216. But I just need that to be on the bottom of a fraction, so I already know ahead of time that it's going to be a negative something, right? And I just got to figure out 6 times however many times it makes 216. So I'm going to go and do 6 times 6. I know that's not 216 because that makes 36. So I'm going to go and do another 6. Right? And I'm not sure what 36 times 6 is, but I'm going to go ahead and try it out here. That 6 times 6 is 30, 36. 6 times 3 is 18, plus 3 more, 19, 20, 21. And I think we had this one before, so similar to this. So it's going to be 3 times, right? So we know it's going to be 6 to the negative 3 makes 1 over 216. So my answer for log base 6 of 1 over 216 is going to be negative 3. All right, and the few at the bottom, and it just says, the direction just says, simplify each expression. Right? So if we use what we just learned today and we simplify this, and let's just say this is equal to x, right? We don't know what that is. Right? Right. So we're saying 12, or sorry, log base 12 of x is equal to, and then that's going to be equal to the power here. So that's going to equal log base 12 of 144, right? So what is x equal to? Well, x has to be, right? Because we're asking, what is this whole thing equal to? Well, it's equal to x, but remember, we just wrote x in because we didn't know what it was equal to. So what would x be? Well, x would have to equal 144. Right? So this whole thing is actually just equal to, this whole expression is just equal to 144. Okay, so you can just utilize the definition of a logarithmic equation written in terms of an exponential, or an exponential equation written in terms of a logarithmic. Okay, so similar idea, right? So let's say, I don't know what this is equal to, right? What this expression, the whole thing, what is it equal to? So I'm just going to go ahead and call it x. Okay, so I'm going to go ahead and write this as a logarithmic equation of log base 5, because this is an exponent base 5. So log base 5 to the, or of x, and that's going to equal the power, which is log base 5 of 17. Again, same idea. X would have to equal 17. So my answer to 5 to the power of log base 5 of 17 is equal to just 17. Okay, that's just your answer. This is just your answer. Okay, so the last couple ones we have, and we're going to say x log x of 72. And some of you guys may know the answer already, but I'm going to play like I don't know, and I'm going to call this, I'm not going to call it x because there's already an x in there. So I'm going to call it y. Okay, so I'm going to rewrite this as log to the base, log base x of y is equal to, and the exponent is log base x of 72. And that means that my y would have to equal 72. So y is actually 72. That's your answer to x log base x of 72. Okay, last one. Again, don't know what this is, so I'm going to go ahead and call it x. Right, so the way I'm going to write this is, so in case I went a little fast, the very last one should explain it. Because this is base 9 for exponential, I'm going to go ahead and write this, rewrite as a logarithmic base 9 of the equal part. So log base 9 of x, and that's going to equal, and then that's going to equal my exponent, which is going to be log base 3 of 20. All right. Now, we can't say, now in this case, we cannot say x is equal to 20 because they're not the same on both sides. You guys see that? So maybe, you know what? I need to change that 9 to a base 3. All right, so maybe I should start over, okay? And it's going to be the same kind of idea. Let me start over again. And I'm going to go ahead and change that really quick. Okay, so I'm going to rewrite that as, instead of that 9, I'm going to write as 3 squared, like that. So that's actually 9. And then to the log, or excuse me, to the power of log base 3 of 20. And all of that is equal to x. So that's what I want to do for this last part. Okay, I'm going to scroll down for a second. And we know with the exponent that if you have an exponent to an exponent, or then that means that you can rewrite it as 3 2 times log base 3 of 20 equal, sorry, that equal should be big, equals x. Okay. And then now we can rewrite this as, since this is base 3, we're going to go ahead and do log base 3 of the equal part, so of x, and that's going to equal the exponent, which is 2 times log base 3 of 20. Okay. And this is pretty close, right? We're getting close because we have log base 3 of something and log base 3 of 20. And this just means that there's two of them. So guess what? When you have two of them, we need to write it as two of them. So let's rewrite it like this. Log base 3 of x equals log base 3 of 20 plus log base 3 of 20. Okay. So now this kind of looks right, but it's kind of wrong as well. It's like, well, how do I make that right? Right? I mean, log base 3 of x is equal to log base 3 of 20 plus log base 3 of 20. How do I make that right? Okay. So maybe we went a little too far. Okay. So maybe you can go backwards a little bit. Let's say, you know what? Okay, I know this is what it means. This is what it means, but that doesn't really help me. Okay, if I only have one of them, it would help me. I can say x equals 20. So I may need to go back. Sorry. So I may need to go back and rewrite what that 2 means in place of that log base 3 of 20. And if you guys may remember, okay, that you actually can take this multiplication and bring it to the back of the 20, and it serves as a exponent instead. Right? So now we will have a little better looking version of this. So log base 3 of x equals log base 3 of 20 squared. And now we know that, and now we can see that, okay, these are exactly the same. And we know that, sorry, now we know that 20 squared is the same as x because the log base 3 and the log base 3 are the same. So that means that x has to equal 20 squared, which means x is equal to 400 because 20 times 20 is 400. Okay, that one was a little tough, but that's a wrap. Okay, guys.